Okay, so we continue with some more examples on divisibility. So this is again proved by induction. That 1, 8n minus 1 is divisible by 7. This is a very nice exam question, and I've seen it several times in exams. So the proof, step 1. Step 1, you have, we need to show that. So you show that the statement is true for n is equal to 1. So which set are we given here? So we are given a positive integers. So for n positive integers. So I want to show that it is true for n is equal to 1. So is that so? N 1 minus 1, this is going to be 7, which is divisible by 7. Hence, shown. Then you go to step 2. Step 2, we just make an assumption. So we assume that the statement that the statement is true. I don't know what's happening. It's true for n is equal to k. That is 8k minus 1 is equal to 7m. So from here, if you want, you could go straight and say 8k is equal to 7m plus 1, because you know that you're going to need this in the step 3. Step 3, we prove that the statement is true for n is equal to k plus 1. That is 8k plus 1 minus 1 is divisible by 7. So if you expand this, we're going to get 8k multiplied by 8 minus 1, which is the same as 8k minus 1. And what is 8k from step 2? So you say by step 2, we have what is 8k? We have 7m plus 1. Then we multiply by 8 minus 1. If you expand this 7 by 8, we get 56m plus 1 by 8, we get 8 minus 1. This becomes 56m plus 7, and we can factor out 7 and have 8m plus 1. So if you look at this, since m is, so when you're assuming for m here, you can say where m is also a positive integer, or let's just say a natural number, it's fine. No, not natural number. Natural numbers are all positive, so it can be negative, we don't care. Let's just say it's an integer. Okay, so we have that. So we can go to step 4 and have what in step 4? So in step 4, I'm going to say, since the statement is true for n is equal to 1, for n is equal to k plus 1, then is true for n is equal to k, and hence true for all n positive integers, like that. Very easy, but very
Sir,
nice. Yes.
is this the only form in which they bring questions on divisibility?
Yes.
Oh.
And the complicated one is the one that is coming now. So for step 3, don't get confused. Step 3. Step 3 depends on step 2. So step 3, you just substitute where there's n, you put k plus 1. So you have 8k plus 1 minus 1. When you expand this part, it becomes 8k multiplied by 8. Then you go back to step 2 and pick your 8 to the power k. So you substitute it. You substitute it here. Then multiply by 8. Then expand, subtract a 1. Then factor out the 7. Then you conclude. So the other example, the second one, example 2. So we have 3. So something is not right here. Quickly do this. Okay, so we have 3, 2n plus 1, no, 2n minus 1, minus 1, plus 1 is divisible by 4. So again, we start with the smallest n. So the proof. So step 1, we show that the statement is true so the statement is true for, so let me orient this part again. Okay. So show the statement is true for n is equal to 1. So let's see. 3, 2, 1, minus 1, plus 1. That becomes 3, 2, minus 1, plus 1, which is 3, plus 1, which is 4, which is divisible by 4. Hence shown. Then we go to step 2. So step 2, we have an assumption here. So we assume that the statement is true for n is equal to k. That is 3 2k minus 1 plus 1 is equal to 4m. So suppose we put 4m here, where m is an integer. So it shouldn't be positive. It can be a negative integer, it's fine. Okay. Then we go to step 3. Step 3, we prove now here. So we prove that the statement is true for n is equal to k plus 1. That is 3 2k plus 1 minus 1 plus 1 is easier by 4. So here we have 3 2k plus 2 minus 1 plus 1, which is 3 2k plus 1 plus 1. So if we go back to step 2 there, we can realize that that can be written as this. So you can write it in any form. So let's go the way we are doing the other questions. So just pick it direct. So you say 3 2k multiplied by 1 over 3. So 1 over 3, because 3 to the power negative 1 is equal to 4m minus 1. So if I just pick 3 2k is going to be 12m minus 3. So if we substitute in the other equation, we're going to have 3, the 3 to the power 1, so to just be 3. From there, we have, so I've taken the 3 to the power 1, and then the 3 to the power 2k, I bring in 12m minus 3, and then we have plus 1. So let's see if this will be divisible by 4. If we expand this, we're going to get 3 by 12. We get 36m. And then from there, we have minus 9 plus 1. So this becomes 36m minus 8. So can we factor out 4 from this? Can 4 go into 36? It must, because 12 goes there, and 4 goes into 12. So 4 go into, so it must go 9 times, yes? So I'm going to have 4, 9m minus 2, which is divisible by 4. So we can go to step 4, where we say, since the statement is true for n is equal to 1, n is k plus 1, then it's true for n is equal to k, and hence true for all n positive integers. like that. So the idea is just the same. We haven't changed anything. We just did this question the same way I've done other questions. So I hope you liked it. Any question? Any question? Just ask.
Like clear.
It's clear?
Yes, for me.
Okay, that's good news. Okay, so if everything is clear, then we'll end here today. So you have a good day. I'll communicate about the test.
Thank you, sir.